Welcome you all the eminent panelists once again to know your views and the potential of the AI in the data center field especially. And there were very nice insights we received through the presentations. AI is not just increasing compute density, it is also redefining the thermal architecture of modern infrastructure. The question arises, is AI creating problem or it is trying to fix the issues? So starting with the general question, Dr. Srinivas first, what are the advantages and challenges of using AI-based thermal management systems in modern data centers?
You see,
Dr. Srinivas.
like as I said earlier, right? It is actually a boon, because having static approaches depending on peak capacity is a gross underutilization, a lot of energy wastage. So naturally, using AI is a great leveler and also a great role for optimization. So, like we saw in the previous some of the presentation, right? You can use it in predictive analytics, like just predicting, what will be the peak load somewhere, so you can plan based on that the right cooling strategy. Or you can look at from a more perspective of just doing an analysis of different parts of the data center where it is, which kind of locations is taking more heat, so you can provision more, maybe higher costlier chillers there, where for the other places you may look at a cheaper infrastructure. And then the ultimate is it possible even to give up artificial but bring in natural air based on what is the ambient temperature and give it. So all I'm saying is bringing data driven approach is going to provide you the benefits in terms of reducing the overall energy consumption, and in fact it may leave a lot of carbon credits for you on the table. So all I'm saying is it's a sky's the limit. What process you want, you collect enough data from the sensors, use it optimally. It could be predictive analytics, like what I predicted in terms of peak usage, or it could be prescriptive analytics in terms of what are the optimal combinations of the fan speed versus the chiller temperature, what will be the optimal temperature for energy consumption. So you can use all kinds of combinations. So I think using AI is a win-win scenario, and I think not using AI will really, you're losing out a lot in terms of leakage of
Yes.
temperature.
Yeah, thank you very much for the vivid details you just shared with us. And the sky is the limit, you rightly says that. Coming to Mr. Ravi Kumar Sahu, what are your views about the advantages and challenges of AI-based thermal management systems?
Yeah. So, as I told you, so first of all, means as uh, in the previous speaking, so with the help of AI, what we can do is, so best thing what I've said is about the okay, just forget about the flute. So it's about means see, as when it comes to AI, so energy is very, your energy consumption and your water consumption are the two, you can say, or heat rejection, or whatever the heat we are throwing into the environment. These are the key parameters, or you can say concerning things, which is we are talking about. So how about how to means when we talk about the energy, so with the help of some AI models, let's say your digital twin models, which we are discussing, or which we are trying to implement globally in some data centers, we can predict how your data centers is performing in terms of operations. So whether some losses is happening, some hotspot formation is taking place, whether how, whatever the your, let's say, chiller operation is up to, whether that is required or not, or it is over consuming. So with the help of your digital twins, we can have a real time model of your actual data centers, what is happening now, and you can also predict what can be, let's say, a failure, or what can say your hotspot analysis, anything which you can, as per the modeling we have. So that is the first thing uh, about the energy savings we can have by using AI. Second thing is your water. So as of now, means as previous speakers said about some water generations from generation tech, that is also a very key thing. So I think energy savings, your sustainability, water usage, water these are the big key things we can, uh, uh, where the AI has a solution on. We have to work on that. And I do not find means we have to more expose, or we can say more utilize how we can think, use AI to think about these issues, or how we can have a, you can say, a better cooling, or you can say better infrastructures over the time by using AI. Yeah.
Thank you very much, Mr. Ravi, for sharing your insights about the uses, and AI is still in the progress mode. Digital twin is a good idea. Coming to Mr. Swapnil, what are your views about the advantages and challenges of using AI-based thermal management?
Sure. Uh, Thank you, Mr. Gopal Krishna. So, of course, as I previously also pointed out, uh, I just, probably give you an example. So, with one of our customers we are engaging with right now, they gave us a complete profile of how their data load is changing or IT load is changing, on an hourly basis throughout the year, right? And then we have to then, match our cooling performance, saying, considering that variable IT load. And what we understood was that because we are also interfacing with, say, ambient conditions, which are air is changing, humidity is changing, your airflow is changing, your IT load is changing. It enabled us to create, very ML based model where we can utilize and see, how we can match and, consider that heat load and provide cooling in the same way. So a lot of new techniques around, how do you actually, see a lot of this data stack come up with, the right model, which can then have both a predictive as well as prescriptive, output is definitely emerging and it's being put to use. And gone are the days where, you have to just rely on a very static architecture, especially with AI workloads, which can go to peak in seconds, right? So, for example, when you are building a data center in the past, it could be, up to 10 to 30 megawatts, and your CPU loads, even if they engage, they go from 30% to 60%, your spike is very small, right? But when you have GPU loads and they engage in milliseconds to from inference to training, your peak load spike can be huge. And that's where you need to be having more flexible architecture around both your power management, IT load management, and then interface it with the right cooling solution. So I think there's a good time to take a leap forward and see where your right AI side, which is managing or kind of orchestrating a lot of this flexible uh, demand balancing, can interface with the right emerging thermal architecture. And it's not just chillers anymore. And that's what we are showing, that, chillers is just one, but using natural air, dry cooling, or probably then extending it to, water positive cooling, which Rovo is doing. These are all, viable options where you can actually come out ahead and, break the status quo about what is happening today versus what can be done in the future with right tools.
Thank you for sharing your thoughts, Mr. Swapnil. Coming to Mr. Santosh, what are your views about the advantages of using AI-based thermal management in the modern data center, though you are in the utility sector?
Yeah, as I was saying, in the utilities planning section, the conventional methodology is always to go for peak load designing. And there are, of course, disadvantages to that you build capacity and which is used probably only for 20 or 25% over the year. So moving towards an AI based would definitely help in planning the utility side. And as I said, one thing is that studying the load pattern, which probably the experts here also are already into the cooling applications for data centers, know that. But I've been on the infrastructure, not much exposed to the data center load. But I'm just putting my thought across here is we can study that and then select those modules, be it steam-based chillers or small power producing plants. Those can be so moduled that the it will be multiple modules will come online as the load varies. This is number one, what I was explaining to you. Number two is then getting into a deep dive into the entire data analytics and study how it then further varies. I mean, is there a pattern which remains consistent or it keeps varying? So if it's varying, then you build algorithms based on that data to manage the loading or turn down or put some VFD system, so that we try to align individual equipment's best operating points along with the load. This is something which can be definitely done. Yes, it requires AI inputs coming from this, developing algorithms and then acting it on the utility side. This can be done. And these are my two thought processes here.
Thank you very much for sharing your views. Mr. Santosh, while you were talking about the utilities, so how can AI can be used to optimize cooling system in utility and power plants to reduce energy consumption?
See, what I was telling is that every equipment, be it a chiller or be it steam based or electrical based, it will have a best operating point. Now, if it has been size, if you have a chiller load of say maybe even a 10 kilowatt, and you are having multiple of two of each, 2 kilowatts, so you will build a pattern into system of owning those system based on how the demand increases or reduces. And in further to that, if there is a further dynamics which is it's going to change based on the load on the data chips or the data center, then we can further modulate, saying that selecting the these loads to come online before the load actually comes in, giving a pre input coming to these equipments, we will start and be ready for meeting those demands. This is something which is done in boilers or in power plants also. You have those feed controls which are feed forward or feed backward feed. So this can be taken from those signals, keep those modules on, and then as the load comes in, it is able to meet the requirement. So this is what I said, deep dive into it and then build algorithms to further optimize those multiple modules of chillings.
Thank you very much. Diving and using the AI.
Yeah.
Okay, coming to Dr. Srinivas. While you were presenting your talk, you talked about the AI to optimize energy requirement, and you even talked about the predictive and prescriptive models of AI and all data centers to targets with that. So in what ways can AI-driven optimization reduce cooling energy consumption by, say, 40% or 50% in the data centers infrastructure?
Exactly. Yeah. So as I said, right, I already mentioned the different use cases. See, let's take a predictive example. As I said, doing something with peak load, workload, peak requirement of heat, it's a wastage of energy. Instead, if you can do a predictive model of how it's been consuming over the past few cycles, use that, and then based on that, appropriately, increase the provision, the cooling, rather than keeping every time at the peak load. That saves a lot of energy. Then, from perspective of just looking at the source, do you really need sometimes internal energy generated by chillers, etc., or can you use the ambient by just open free air? It's a great saving, right? If the ambient temperature and the ambient air can come in, it can be a good tool to sufficiently capture that. That's a great optimization. Then looking at the location, right? If you map out the whole, data center and see which are the areas which are, potentially high heat source, you can actually target, high chillers and high cooling there, whereas the others which do not necessarily get heated based on the historical data, you actually, can reduce the whatever called use of the high cost chillers. So then you can also look at over a period of time through the day, temporal modeling of the heat capacity, and based on that you can kind of use a model to understand what kind of capacity should be provided in the generation of the cooling during what time. So across all dimensions, the goal is very simple: reduce the energy consumption by use of data from machine prediction, then looking at geographically located different heat points and differential heat requirements. Then from a source perspective, can you substitute requirement of actual chillers with something from ambient air? And not only that, even in terms of when you are trying to see the flow, there are now techniques whereby you can control the flow by optimizing based on the dynamic requirements. So I think sky is the limit, as I said, right? It depends on how much sensors you put, how much data you captured, and how you're using that to actually calibrate your cooling source and cooling perspective. So with all of that, there is definitely a huge, in fact, as I said, right, the DeepMind case study where the Google DeepMind have actually used this in combination of all of these use cases in their data center. They have shown 40%, with really low, what do you call as PUE. So it's a given that this is the way forward. Only challenge which I find is sometimes, these analytics algorithms are themselves not so reactive, in the sense that even the number crunching, the dynamic nature that is required, can they give real-time output? So it's sometimes a challenge that you get the data, can the real-time output be used in applying to that? Sometimes that creates a challenge, because ultimately the number crunching in AI itself requires some kind of a adoption, right? So maybe you can look at more common patterns, use that, already load that into the firmware, and do that using only inference time rather than training those algorithms. So I'm just trying to see that. But one important aspect which I want to mention is, a lot of times the challenge is in a lot of times the sensor equipment, etc. Right? Even the hardware in the data center, they are legacy. They may not be amenable for all the data capture which is required for AI. Though we say we can do all the things in AI using that, but the sensor data is the most important. That's what is going to give you the data for maintaining and creating AI models. So if all of the machines are amenable for putting sensors, new ones I know they have sensors of all kinds, but if there's legacy machines which are continuing in the data center, which they have to be retrofitted, you need to have a right mindset to fit right sensors in other places to collect data, because without sensors there's no AI. Simple.
Very nice. That's a fabulous idea about it.